like, share, subscribe.
Hey y'all, welcome back. Number 81 here says, select two of the following choices and place them in the blanks below so the resulting statements are true. So we've got four equations and they all look like they're exponential growth equations. Actually, it looks like we also have, this might actually be a half-life problem. Let's read a little further. And then we've got these four numbers. So it says the amount of a certain radioactive substance decreases by 17% every 20 years. If the initial amount of the substance is 100 grams, then the amount of A in grams of the substance remaining after T years can be modeled by one of these functions. According to the model, 30 grams of substance will remain after approximately blank years. So here we got to know how to set up this equation. So at least the first part of the equation, which I think is going to be, that's the only thing we really need to look at. You can see the exponents here are going to be the same on all of those. But when you write an equation, and I'm just going to kind of give you the generic template for an exponential equation here. Although, of course, like with different contexts, we might modify this a little bit. But in general, if you've got an equation like this, the A value here is going to be your initial amount. And B is going to be either the growth or decay factor. Okay, so if it's growth, which this one isn't, but if it's growth, meaning that like a population is growing by some exponential rate or something like that, if it's growth, then B is going to equal 1 plus whatever that growth rate is. And if it's decay, then that B value can be computed by doing 1 minus the rate. So just to be careful there, this one is saying that the amount of the radioactive substance is decreasing. So this is going to be decay. So we are going to compute B as like 1 minus the rate. So the initial amount here, it says the initial amount is, here we go, the initial amount is 100 grams. So right away I can, cross out these two because I want my initial amount to be 100. And then it says that it decreases by 17% every 20 years. So as a decimal, 17% is 0.17. So you'd have 1 minus 0.17, and that's going to be 0.83. So we can see that our equation is going to be this guy right here. Okay, it's not going to be this one. This one's going to try to throw you off because it has the 17 in there. But you have to know that the actual multiplier here, this growth factor and decay factor, is always 1 plus or minus r. Okay, so we know this, and then it's saying, according to the model, 30 grams of the substance will remain after approximately how many years? So you could plug these in to T and see which one equals 30. That might be the fastest way to do this. Otherwise, you are going to have to solve an exponential equation. So I think what I'll do here is, take a look at the time, and I'm going to work this out sort of the algebraic way versus just like plugging it in and see, which one's faster. So we've got our A of T, that's what we're trying to find is T here. So that's going to be 30 is our final amount. So 30 equals 100 times 0.83. The power of T over 20. The way you would work this algebraically is first you would divide both sides by 100. So 30 divided by 100 is equal to 0.83 to the power of T over 20. Now I'm going to reduce this. 30 over 100 can reduce to 3/10, just to kind of clean that up a little bit. And then to isolate this exponent, we need to rewrite this as a logarithm. And this is where, I start to think, well, if you don't know how to solve this, then you're probably better off just plugging in the answers anyway. But I do want to show you algebraically how you get there. You do want to rewrite this as a logarithm. So it'd be log base, let's see if I can get a base here going. There we go, 0.83 of 3/10 is equal to T over 20. And then I would multiply both sides by 20 to isolate the T. So this is going to be something that you just type into the calculator. Oh, what happened there? I guess I didn't copy the whole thing. Equals t. This would be something you put in the calculator, although since you only get a scientific calculator, you would need to use the change of base formula and rewrite this logarithm as log of 3/10, or I'll just go ahead and write that as a decimal, just to kind of make this not so crazy, divided by log of 0.83. And so this is going to be what you type in the calculator. So yeah, let me go ahead and pull up my calculator here. Bear with me. Where is my calculator? Why is it not showing up? There we go. I'll just make this a little smaller, I guess, so I can make it fit. I don't want to cover up all the work here. All right. So anyway, I'm using a TI-84 here. You won't get to use the graphing calculator, but the calculator you get to use will do everything you need to do here. So 20 times, and then you're going to type in a fraction here, log of 0.3 divided by log of 0.83. And hopefully you're noticing that this is already taking quite a bit of time to not only solve, but type it in and make sure everything looks good. We do get, let's see, the closest number here is going to be 130. So yeah, so our answer here that we want to plug into the second blank is going to be 130. So yeah, I would definitely, even if you had to go through all four of these answer choices, it is probably faster to go ahead and just plug those into t once you've identified the equation and just see which one actually equals, the closest thing to 30. So that's it for number 81. Thanks for watching, and y'all have a great day.